Hi, Mike Mays here. Here's another video about topics in mathematics that make Scratch programming a little easier. It's something that comes out in a book that's coming out, Math Hacks for Scratch. That'll be out next year from No Starch Press. So let me go in and look at some Scratch things to do. Today I thought I'd talk about how to do fancier bits of multiplication. So if you look at what the operations are that are available in Scratch, the operations that you have are the four functions of arithmetic: addition, subtraction, multiplication, and division. If you want to repeatedly add a number to itself, like you want to add 2 to itself 4 times, you could do it as 2 plus 2 plus 2 plus 2, and you have to stack up a whole bunch of the plus operations to make that show up as an answer in Scratch. Or you could do repeated addition as a multiplication problem. It would just be 4 times 2, and multiplication handles repeated addition. Well, how about repeated multiplication? Lots of times you'll see in a math setting repeated multiplication handled by an operation called exponentiation. So 2 to the power of 3 would be 2 times 2 times 2. 2 to the power of 3 is a handy thing to have, and that's not something that's built in to the basic operators in Scratch. So if you are going to do some arithmetic and you need to have access to raising a number to a power, repeatedly multiplying it by itself a certain number of times, we need to tell Scratch how to do that. Well, one way to do it would be to set it up as a iterated process. You're going to multiply a number by itself so many times. That sure sounds like a loop. So let's define a block that would do that. I'll call my block, make a block. Let's say the block's name is power. And I'm going to have another way to do it later, so I'll keep track with power 1. And what I want to do for power 1 is put in a number that I'm going to be repeatedly multiplying by itself. I'll call that the base. And I'll put in another input for the number that is going to be the number of times that it's multiplied by itself. That's the exponent. So now I've got a block set up, and I just have to say what to do. So I'm going to keep track of the result of this with a variable. I'll call the variable result. And again, result 1 kind of makes sense because I'm going to have a different way to do it, and result 1 shows up over here. Now, how do I want to define it? Well, I'm going to start with an initial value of 1, so set result 1 to 1. And now I'm going to keep track of how many times I'm going to multiply it by itself. So I'll put that in as a loop. So let's find a loop. We will repeat a certain number of times, and the number of times we want to repeat it will be determined by the exponent. So I'll repeat exponent number of times, and I want to bump result by another factor of result there. So let's do that. I'll put in an operator. So let's see, set result 1 to be, I'll take the value that I've calculated so far, starting with 1, and I'll be building it up from there. So result 1 times the base. And that's all we need to make that work. And we could set this up, we could embed it into a big Scratch program, but we really don't need to do that. Here is my block that I've defined now. Let's see how it works. Suppose I want to raise 2, that's the base, to the power 3, that's the exponent, And I'll just click here and see what it reports as a result. Sure enough, it came out to be 8. You could do other things. We could raise a negative number. It works just as well for negative numbers. Let's do -3. Let's do that to the 4th power. Let's anticipate what the answer is going to be. That should be -3 times -3 times -3 times -3. 4 minuses, 2 multiply 2 together to get a plus. So the overall result of that's going to be positive, and it's going to be 3 times 3 times 3 times 3, 9 times 9. That should be 81. Let's see. 81. So understand how that works. And here is then one way to calculate powers, and you can have this sort of as an extension of Scratch arithmetic to build that in. Now here's something that is a little bit fishy about this. I mean, anytime you have a program that you do, you sort of have to see what kind of assumptions you're making. And here, one big assumption is that the exponent that I'm working with is a positive or non-negative integer. 0 works, -3 to the 0 power, since the loop was started with a result equal to 1, and looping 0 times doesn't change that. 1 comes out, so -3, anything to the 0 power is 1. I think even one that comes out to be undefined as far as Scratch is concerned, 0 to the 0 power, it's happy to call that 1. You could decide whether that's correct or not. But one that goes wrong, if you take a negative exponent, so you're going to do 2 to the power -1. 2 to the power -1 is conventionally 1/2. And this loop doesn't know that because it thinks it doesn't loop through any times from its starting value of 1, and so it reports the result of 1. So you have to be careful how you use this, or you have to write the program to be a bit more complicated so that you're screening out all these odd special cases and letting the program treat them differently to get an answer. Okay, here's another approach completely different that doesn't use a loop at all. Under the operator menu, there are a collection of mathematical functions that are available. And among the mathematical functions are this 10 to the power, that's a particular exponential function, that's a power of 10. And another power that's available in this menu is log, L-O-G. 10 to the power and log are inverse functions. That means one of them undoes what the other one does. So if I try that, just to show you what that means, so let me put this in. 10 to the power of log of, and now put a number in here, say 5, and see what that evaluates to. Well, 4.9999 essentially evaluates to what you got back. You could do it, stack it the other way. You could do the log of and now put in 10 to the power of. So put a 5 there, and again, what you apply one function, you get an answer. You apply the other function, it gets you back to what you started with. So 5 comes out. Now the point of this is that by playing with the relationship between 10 to the power and log, you can essentially change the base so that 10 to the power of log of 5 is 5. So if you wanted to do 5 to a power, you could do 10 to the power log of 5 and then put the exponent there. And you can raise a power to a power by multiplying exponents. So it's just a product in the exponent that says what the answer is. We can use that as the basis of defining another approach to exponentiation. So Let's go back to my blocks. I'll make another block. This one is power 2, say. I'll add an input, again, a base. I'll add another input, exponent. Okay, and now let's define power 2. So we'll take another approach to this. So what I'm going to do is take to get the power, what I want to take the power of, it will be the log of, so I'll make it a variable, another one, result 2. And set result 2 to be 10 to the power of log of, and now here I want to have, so I'm going to raise it to a power by doing multiplication in the exponent. 10 to the power of, it's going to be the log of the base times log of the base times the exponent. And that's just a one-step thing using the inverse of the exponential function, the log function, to let me convert the base before I do this. And now let's try this one out and see how it works. So this second approach to power is, well, let's try the one we had. So this is going to be showing for result 2. Let's do power of, let's do 2 to the power 3. Click to run it. And there's the 8 that comes out, just what I expect. And here, 2 to the power minus 1, with this approach, it does know that it's a reciprocal 0.5. For there's 1/2 for 2 to the power minus 1. It even does fractions, so that if you have 2 to the power 0.5, that is conventionally the number that is the square root of 2. And if you've seen the square root of 2 to the power 0.5, there's the value that comes out for the square root of 2. So we've got two completely different ways of calculating power so that we can do this repeated multiplication. One way is to do a loop, and the other way is to just translate so that I have a general exponential function available from this specific exponential function that they give. And sometimes one way is going to be better, sometimes another way. If you drop this into a program that you're writing, it's really important to keep track of what you expect the inputs to be. What kind of values do you think the users are going to have? And to make sure that the program will give you a correct output for various possible inputs that the users would come up with. My experience is that users are amazingly inventive in finding ways to break the best programs you've ever written. But at least this is a mathematical way to look at two different strategies to do this calculation. So that's my little dose of Scratch for the day. I'll see you again later. Bye-bye.